Example 6. Resolve a force into rectangular components. While digging in his garden, Will pushes his shovel into the ground with a force of 630 newtons at an angle of 70 degrees with the ground. Draw a diagram that shows the resolution of the force that Will exerts into rectangular components. So here's an image of Will here, and he's shoveling into the ground. Now, what we've been told is that there's 630 newtons of force going into the ground, and he's doing so at a 70-degree angle. Now, you might notice that behind here I have an image of a triangle that you cannot see that clearly, but you can see it's there. Let me do one thing to it. I'm going to change its transparency, and you'll begin to see that this triangle represents how Will is working. We have a hypotenuse force of 630 newtons, and there's 70 degrees, and we want to find the x and the y. Well, as you look at this right triangle, you'll notice that it's just what I said. It is a right triangle. That means we have a 90-degree angle. We have learned that anytime you want to solve a right triangle, you can use psi y cos x, tangent is y over x. So if I wanted to find the x component, and I am given a hypotenuse component, the trigonometric function I will use is cosine because it is x over h. And again, that is what this value is here. It is an h value. Let me rewrite that a little bit more clear so we can see it easier. It is an h. So we could say that cosine, remember you always select the angle that's attached to the x-axis, but that's not the 90, which would be this angle here, of 70 degrees will be equal to x over hypotenuse. And again, our hypotenuse is 630. And specifically, it's newtons, so that will be our final value. So here I multiply by 630 on both sides to solve. Those go away. And when I type this in the calculator, we'll find out what x is. So I'm going to go to my calculator, and I'm going to clear this here. We'll go cosine of 70 degrees, and I forgot to put the 630 in the front. Is 215.47. 215.47. So that means there's 215.47 newtons of force going to the left. And now, since it's going to the left, you see how when he's shoveling this direction to the left. We're actually going to refer that as being negative 215.47 because it's going, again, to the left. And so vectors give a direction. This is a direction of left. Now the y value is going down, so we will again get a negative value there. So let's go to find the y. We have a h. We want to find a y. We can use sine. Now again, you could use Pythagorean theorem now that you know this value, but I'm just going to use sine. So I would say that sine of 70 degrees equals y over the h value, which is 630. Again, I have the one step to solve this. I multiply by 630. Those go away. And so I will have h times sine of 70 degrees. So we go to our calculator. I'm just going to copy this down to make it quicker. But instead of cosine, I'm going to change this to sine. The easiest way, just to backspace the C and the O and replace it with an I and an N after the S. Now I have 630 sine 70 degrees, which is 592.01 when I round. So 592.01. 592.01. And again, we are going to make that negative because it's going down. So 592.01. And our answer, since it wants it in rectangular components and it's vectors, you would use these symbols, not a parenthesis, but these brackets. This means it's a vector. It's heading in a direction. Negative 215.47, comma, negative 592.01. This there would be the answer. And now, secondly, I'm going to show you another way we could have done this. We could have as well taken, let me block this off so we can see, a second mode of doing this is to use the calculator. Now, how do we use the calculator? We would use these brackets in the calculator. We would say, now remember, you can either do, in the calculator, you can say brackets of x comma y is equal to brackets of h or your r, if it's a radius, either way, h and r are identical, times the angle of whatever theta is. Now, these are the buttons you type in the calculator. Those will be congruent. In this case, they gave us an h of 630, and the angle is 70 degrees. So if I type that in the calculator and press enter, I should get the x and y. Now, the calculator will probably give me the positive because it has no idea of knowing that these are going to the left. The way you would have to determine that is you'd have to tell it from the origin how many degrees it's going. You see how this vector, the origin here, if you're starting from the origin, this would be the origin, and it would not be 70 degrees anymore. It would be all the way around this way. So we'd have to change the angle. But for the sake of time, it's easier just to show you how to type this in. So I'll go over the calculator, and I'm going to press Control and then the parenthesis here to get that bracket. My h value is 630, and then we press a comma, and now we have to press the angle button. So come over here, and you're going to press the book button. When I press this button, it should pull up, and you see here's the angle. So you'll hit that, and now we're going to put in 70 degrees. When I press enter, it should automatically change it to an x and y. And you'll see it got these same numbers, 215.47 and 592.01 when we round. So this gave us the same values. You would just then say, okay, as I observe the picture, it's going left and it's going down. That is the vectors, and so I would make them negative. So when you type that in the calculator, again, this would give us that same 215.47, which we would then change, and it would also give us the 592.01. So that's a different way of using the calculator. Either way will work for you, but those are both the techniques. Now you have one to try. You can either use one here. You can either draw the picture and use the psi y cos x tangent is y over x, or if you so desire, you could use the calculator by typing in the h and the angle.